Good morning, everyone. Welcome to the second talk of the day. I'd like to introduce Colton, who's going to be talking to us this morning about Decorators.
All right, is this thing on? Can you guys hear me? Sweet. All right, so good morning. Welcome to PyCon. I'm super excited to be here. This is my first PyCon, both attending and as a speaker. So, yeah, there are a lot of you. When I found out they put me in the keynote room, it was a little bit horrifying. But I'm going to be talking about Decorators. And it's going to be a fairly basic. We're going to start right at the beginning and how we create Decorators and go through it. But before we get there, just want to put in a little plug for my company, SaltStack. Apparently some of you are familiar with it. They're the reason I could be here, so I'm very grateful to them. You should come visit our booth. We're in the Expo Hall, 811 I think is our booth number. You can learn all about Salt. We are a remote execution, configuration management, automation platform. You can use us for whatever you need. So it's really exciting stuff. We also have an open space tonight, 523A. I think I have the right number on that. At 5 until 7. And Tom Hatch is here, the creator of Salt, and he'll be there to talk about Salt, so it's exciting. And we're going to be at the sprints on Monday. So if you want to come contribute, do it. All right, so the plan for this talk, we're going to start out with defining what a decorator is. We're going to construct our first decorator, and then we're going to explore how they work a little bit, and I like to do this just because I feel like if we're going to be using something in our code, we should know at least at a high level of how it works, because otherwise, if we're just copy-pasting code from examples we find on the web, we generally are going to run into problems that we otherwise wouldn't. I'm going to briefly talk about the right way to make decorators. And if you want to learn, I'll talk about this more later, but Graham Dumpleton is actually doing a replacement talk, first track, last talk of the day, and he's going to go way deep into the right way to make decorators. So if you're interested in that, make sure you go to that talk. And we are going to hit a couple of examples as well. So what is a decorator? We've probably all seen the basic syntax of a decorator. So we have my awesome function here, and it doesn't do anything. And on top of it, we apply a decorator using this at syntax. So what is it actually doing? Decorators at the most basic level wrap functions. And this can mean a variety of things. We can add a functionality to an existing function without modifying that function at all. We can modify its behavior, whether that's as simple as making the return type a string or much more complex examples. Setup and tear down. This is really useful for testing systems or for database connections or whatever you need. And we can also do diagnostics. We can time our code, whatever we need. So before we get to the actual decorators, let's back up a little bit and define a function. So we know what a function is. We define this functionality and we can call it anywhere we want. And the important thing in Python is that because everything in Python is an object, functions are also objects. And this is important because in some languages, this is not true. And in some languages, you can't easily pass functions around or define them inside of other functions or, do all these things that in Python, we're just used to seeing. And this allows us to do really cool things. We can define our function that prints hello. And when we call that function, it prints hello. We can pass that function, we can assign it to another variable, and then call that variable, and it still retains the original functionality. And I know this is a really basic example, but it's important to realize that we can just pass around functions like any other object. Functions can also create other functions, and this is integral to decorators, at least the way that we're going to create them today. So for example, we have our makePrinter method here, or function here, and as you can see, it actually defines an inner method which it then returns, or an inner function which it then returns, which we can assign to whatever variable we want. So we call makePrinter, we pass in a string, and it actually makes what we're going to call a printer function that we can assign to p. And now if we call p, we can see that it prints such wow. That's my obligatory Doge reference. So this is called a closure, and closures are something we're not going to go deep into. It's a whole different talk. But basically, when we have this function that we define, our inner function closes over the value of word. So it retains this value even once we're done executing make printer. And this is important because we can apply it with many different strings and get a different printer for each, and they each have their own version of the word. Decorators are also closures, or at least they are in the version that we're going to talk about now. You can also create decorators with classes, and actually you have to if you want to do it the right way. And again, Graham is going to be talking about that later today. So much like our make printer is a closure, our first decorator is a closure. So this is a pretty basic example of a decorator, and this decorator doesn't actually do anything. All it does is creates our inner function. It creates a new function which calls the original function, and that's it. And so to apply this decorator, we go back to that syntax we saw at the beginning. We have the @ syntax with my decorator right above our function, which also does nothing. So this is a pretty contrived example, but it turns out that this syntax here is actually what we call syntactic sugar. It doesn't actually, it's almost like an alias. It resolves to different syntax underneath. And that syntax is actually this. Basically what we're doing is we're calling our decorator, passing in our function as an argument, and then it returns a function which we assign to our original function variable. So that's a pretty basic example. Let's jump to a slightly more complicated example, which is also pretty useless, but that's okay. So this is our shout decorator. And we see that the only things we've added, really, are these print statements. We're going to print something before our function, and we're going to print something after our function. And so, and you notice also that because we want to print something after our function, we need to save the return value and return it if we want to keep the original functionality of the function. So if we call myfunc after it's decorated with shout, we see that it prints before and after, and prints are such wow. So how is this actually working? So let's see here. So first of all, let's go to our non-syntactic sugar version, where we're actually calling the decorator. When we first go through this example, we're going to, at import time or at runtime, we're going to define two functions, shout and myfunc. And then we're going to run this last line, which is the decorator being applied. So when we call shout, we pass in myfunc, and here you can see I've highlighted myfunc as it travels through this decorator. The shout decorator actually creates a new function, which again closes over the value myfunc, so it keeps that wrapped function. Even if we apply it to multiple functions, we'll get different decorators that wrap around different functions. We add our additional behavior, like we talked about before, and then we return our inner function and stick it in our myfunc variable. So that's just a basic example of how you can add functionality to another function. So good decorators are versatile. We want our decorator to be able to be applied to any function. If it requires a function to look a certain way or act a certain way, then it lessens its usefulness dramatically because we can only apply it to some functions. And the reason we're writing decorators is so that we can reuse that functionality across multiple functions. So some of the things that we've done with this decorator, I've just kind of left them sitting up there without actually talking about them. But first of all, there's the star args and star kwargs. So if you're not familiar with this syntax, args is a list of arguments, and keyword args, KW args, kwargs, is a dictionary of keyword arguments. If we put them together in a function signature, then we can handle any number of positional and keyword arguments. This allows us, so if we put both of those in a function signature, all of a sudden we can handle any function call. Any number of arguments, any valid configuration of arguments, we can handle them. Those arguments get placed in args as a list and keyword args as a dictionary. So we know what happens when we put it in the original function signature, but what happens when we reference these variables with the star and the star star? This is actually called unrolling. Args and keyword args at this point are just a list and a dictionary. There's nothing particularly special about them. And so you can actually, put a star in front of any list in a function signature and it'll do the same thing. And what it's actually doing is it's taking that list and that dictionary and just sticking all of those values in the function as arguments and keyword arguments. So star args becomes arg0, args1, args2. It just unrolls them into the function call. And star star quargs becomes effectively the key 0 equals quargs key 0, and on. It just unrolls those key value pairs as keyword args. And so that's another way that we can make our decorator versatile. And then, obviously, like I mentioned before, we need to retain the return value if we want to be able to apply a decorator to a function without breaking everywhere that function is called. If something's relying on the return value, then we need to retain that return value. So we've done a couple things to make this versatile, but the problem is we're still not there. And I'm going to go over a couple of examples of why, and then leave it to Graham to talk about exactly how we solve these problems in the long run. The first is dunder name. If we call myfunc.dunderName, we actually get inner, because myfunc is no longer myfunc. Myfunc is actually the inner function that we defined inside of our decorator. And so we can solve this. After we define our inner function, we can say inner.dunderName equals wrapped.dunderName. And all of a sudden, okay, now when we call myfunc.dunderName, we get myfunc. And we can also do this for dunderdoc and the other attributes that we want to save. But there's more problems. What if we wanted to look at the argspec for our function? If we want to inspect our function and say, hey, what arguments do you take? If we inspect it, we're going to see, oh, it takes star args and star star quargs. That's not very helpful. And so this is a little bit harder to solve because we can't, you can't just very easily assign the argspec across. There's no dunder argspec. At least not that I know of. I could be wrong on that. But fixing these types of problems involves a much more complex solution involving proxy objects, where we keep the original object around and reference it, as we need to later, and a number of different things. And to handle all of these, Graham Dumpleton created a library called Wrapped, and it's really cool. This link here, which you can also find on the slides online, will lead you to his first blog post on the subject. He did a series of 10 blog posts earlier this year on the subject of creating decorators the right way. And if you go and so if you follow through that explanation, you can see exactly what goes into a library like Wrapped. And he's, again, first track, last talk. He's running a replacement talk there on this exact subject. And so you should go see that. So how do we use Wrapped to create our decorators? This is the example right off of the Getting Started page for the docs for Wrapped. And we can see that we import Wrapped, and then we actually use a decorator to create our decorators, which is kind of ironic. But we just stick this @wrapped.decorator right on top of our function, and it does all the magic behind the scenes for us. So this is actually cleaner than the example we had before. Now we no longer have nested functions. We can just define a function, and it receives our wrapped variable, and it receives our args and our quargs, and we can do whatever we need to and get out. Now, you might notice there's one difference here, this instance variable. And I'll let Graham talk more about that in his talk, but basically, you can also, decorators are not just limited to functions. You can decorate classes, and you can decorate objects. And so instance actually allows you to figure out what kind of an object you are decorating, and that way you can act accordingly. So that's what that is. So what about decorators with arguments? If we need to define something for the decorator to work on, then we need arguments for the decorator. The most common example, or one quite common example, is in the unit test library. It gives us a number of tools that we can use to modify our tests. In the case of skipIf, we can pass in a conditional, and we can pass in a message. And if that conditional is true, we skip the test and just print the message instead. And so we're going to go over a super simplified version of skipIf, which is not based on the source code of unit test at all. It's just based on the general functionality to show what we can do with arguments to decorators. So this example, I'm sorry to smash so much code onto one slide, but I had no idea how to make this any more simple. So bear with me. We've now nested our functions one deeper. So we actually have, let's go back to that. So we actually have a skipIf function that creates and returns a decorator. And you can notice that we apply the skipIf decorator by just passing in arguments, calling that skipIf function, and then having that same @ syntax. And this, again, resolves to different syntax once you remove the syntactic sugar. So let's explore this line just a little bit to figure out what's going on. We call our skipIf function, and we pass in our conditional and message. And this is a really contrived example because nobody hates Doge. So, but if we did, we would skip this test. So we call this function. It creates and returns a decorator. So you can see the return dec there. And then we immediately call that decorator and pass in myfunc. So the decorator itself doesn't actually get stored in a variable. We just immediately call it. And it creates and returns the inner function. Our myfunc travels through as the wrap function. And then we return the inner function that gets stored into myfunc. So this is, it looks more complex, but it's actually not too bad. If you just realize that we just are calling skipIf, it's creating a decorator and returning it, and then we immediately call that decorator and with our function. Our new behavior here is if conditional resolves to false, then we want to return wrapped, or we want to call our function, or our test in this case, and return its return value. Otherwise, we want to skip it and print our message. So that's back to the original syntax there. So how do we do this with wrapped? I've told you that this is not correct. So what does this look like with the wrapped library? And it actually is the exact same idea. We have an outer function that we define that defines the decorator itself. And so all we do is just nest it one deep and return our dictionary. Whoops. Yeah, return our decorator. And then we can apply it, in the same way that we did with the triple nested version. Yeah, so we create our decorator, and we return our decorator. So let's go over a few last examples. So now you know how to generally create decorators with and without arguments. So what are other ways we can use decorators in our code? And these are going to be pretty simple examples, they can be useful under certain circumstances. The idea is to just show you what might be possible so that you can write your own decorators that actually solve problems that you need to solve, because nobody knows your problems better than you. So counting function calls. If we want to count the number of times a function has been called in our code, that's really easy to do with decorators. So we have this count decorator. And you'll notice it looks very similar to the decorators we had before. The one difference being we have this inner.counter variable. Functions are objects. And with objects, we can define new variables that are part of that object. And so in this case, we're defining a counter variable, we're starting it at 0, and then every time we call the function, it actually looks at the function object itself and increments that counter. And it's a little bit mind-boggling if you've never seen syntax like this, because it can be weird to think of functions as objects that can do this kind of stuff. But But if we then call myfunc 3 times and do myfunc.counter, it says 3. So you can see exactly how many times a function has been called in your program. This one is for timing your code. If you want to keep track of how long a function takes to be called, you could do something like this. And here, we just save the start time of our function, we call our function, and then we print the elapsed time. And so if we call this, apparently it takes 0.0000, I don't know how many zeros, 405 seconds on my laptop to print so example. So take that with a grain of salt. But if you had a much more complicated method, if you had a much more complicated function, you could keep track of if this is taking up more time than you think it should. And you could actually, I don't have a slide for this, but you could combine these examples. We defined an inner.counter variable. Why couldn't we define an inner.timeElapsed variable? And then we could just increment that with the amount of time that our function takes each run. And at the end, we will have information about how much total time our function took to run. And you can expand this to a lot of different examples. But let's go back forward here. So those are all the examples I have. Thank you for coming. My name is Colton Myers again. You can find me online at BasePy. And the link is to the slides. They're also on SlideShare. I think I'm ending a few minutes early, so we have a few minutes for questions if people have them. And there's... There are microphones on both sides, so go to the microphone if you have a question. Looks like we're good. Does anybody have any questions? All right. Oh, you got a question. All right.
Hi there. Thanks for the talk. I saw some cases where there were 2 decorators, one after the other. Can you talk a bit about this incantation?
Oh, sure. So if you remember, let's go back to one of these examples here. I'm just going to go back out to this, and it's over there apparently. Let's actually go to an even simpler example. All right, so this has weird highlighting, but if you remember, so we have our myfunc, and the decorator syntax resolves to myfunc equals shout myfunc. So if you were to apply a decorator to that decorated function, all we do is surround. Let's actually just, I'm just gonna go right here and say, okay, if we had 2 decorators that we were applying, we'd end up with, so let's say my other decorator, and we actually take the decorated function and pass it right in there. So let me just play that again. So, and that is equivalent to, if we put up here, this is not going to work as well as I wish it did. If we had @shout, and then above that we had @my decorator, my other dec. So these 2 decorators up top are the same as doing this. We just call, we decorate it once, and then we call the next decorator and decorate our first decorated function. Does that make sense? So that's what's happening.
Yes. Why don't you pass the function that you want to be wrapped into the inner function as an argument?
Oh, so that goes back to the fact that so the inner function is what you're actually calling, right? When we call myfunc after this is decorated, let's just undo all this. When we call myfunc at the after we decorate it, we need that to act like our original function. So if that took a function as an argument, then all of a sudden it would be called differently, right? The inner function is actually acting as a proxy for our original function, so we can't add arguments to it. And that's where closures come in, because just the fact that we reference wrapped inside of that function means that Python is automatically going to keep a copy of that variable in our inner function. And that's called a closure. So it's kind of hard to see how it retains that variable, but if you look into closures, that'll answer your question a little bit better. Does that make sense?
Yeah. What is the limitation of how many levels it can go?
Technically, you could go as deep as you wanted. I don't know why you'd want to go more than that 3 example where you were passing in arguments, because as many arguments as you need, you could do in a single function call. But technically, you could, just start putting more parentheses, more function calls on the end of that decorator and nest even deeper. But there's not really any reason to.
Thank you.
No problem.
So you mentioned that decorators should return a function. What can they return?
Well, technically, they could return anything, and what they return ends up being placed into our original function variable. So if they were to return something that wasn't a function, all of a sudden, the person who's using my func is going to try to call it as a function, and if it's a callable, it's still going to call, but you know what I mean? Like at that point, if we don't return a function, then we're not staying true to the fact that we want to retain, we want it to be as invisible as possible to the person who's coding. We don't want to actually change the function in such a way that's going to break all the code where that function is called. Does that make sense?
Yep. Thank you.
But yeah, you could return anything if you wanted. Let's go. You read there first, I think.
How does the @static decorator work?
I have used @static, but I actually have not looked at the code. I think it transforms the function such that it no longer needs to take a self variable because it's a static function. It's tied to the class itself. So I'm not actually sure how that's working underneath, but that's part of the Python source code. You could just go look into that decorator. I'm sorry, I don't know the answer to your question, but it's transforming that function in such a way that it's no longer called and with the automatic passing of self, like normal object or methods. Yeah. Does that make sense?
I guess I'll read the source code.
Yeah, I'm sorry I don't know the answer better.
One thing that's always kind of confused me about looking at decorator code is that normally when I see a function, I don't expect it to be called unless it's explicitly called. So here, inner is never called. Where is the call to inner?
So the call to inner is actually, let me just edit this right here. When we call my func right here,
That is the call to inner.
We're actually calling inner because when we create this shout right here, when we call shout, it returns a function, right? And we take that return value and put it right into my func right here, and then we call it here. So we're actually calling inner at that point.
Right. Okay.
Okay.
Thank you.
Yep. Go for it.
Hi, thanks for the talk. Can you say anything about how these decorators relate to aspect-oriented programming?
Sorry, what kind of programming?
Aspect-oriented programming.
I guess I'm not really familiar with that term.
Well, okay, so this is something that is used in Java sometimes, where you I guess you can decorate methods by defining them elsewhere, and you don't even have to put the decoration inside, like above the method you're defining. You sort of define it. Every method that has this kind of name is going to be decorated in some way. Is that possible with decorators as well?
This is getting out of what I really know the answer to, but I think that would fall more under the monkey patching. If you've ever heard of monkey patching, with monkey patching you're modifying somebody else's code without them really being, without them necessarily knowing that you're doing so. And so, you can actually import a module and then go into that module and change things before it actually gets used. And at that point, I think you could go in and actually just stealth decorate that function with a post import hook or something. And but again, that's getting past what I really know.
The more interesting thing would be to decorate everything that currently exists, or everything that has a certain name or that's in a certain module.
As far as I know, there's not like a built-in way to say apply this decorator to all the things. But there might be, and I'm just not aware of it.
Okay. Thanks.
Yep. Sorry? Right. So like I was mentioning before, if you use the add import hook, you could just, you could say what's in this module, what's, dir module, and you can see exactly what's in there, iterate over every function, and decorate it. So it is possible. Let's go over here really quick.
Okay, thank you for the talk. What about inheritance? And I've been running into some problems, overloading functions and methods, and everything gets crazy because I want to keep the decorators and they get lost and all that kind of things. What do you recommend?
So you're saying you decorate a function and then you inherit that class,
Yeah.
and it loses the function. Well, the key is if you want to keep the original behavior when you inherit and then overwrite a function, you have to call the super function, right? And so if they're good about actually calling the parent function, then it's going to call your decorated method. But if they overwrite your decorated method with another method and don't call the super, there's really nothing you can do. You could maybe monkey patch it or something, but you're limited at that point because they've just defined a new method and your old one's gone.
Okay.
That's it?
Thank you for the talk. You said that you can't really import spec args. I mean, you can't really
transfer it across?
Yeah, exactly. So do you know how wrapped does that, or?
Yeah, it uses. Come up and talk to me after. It uses the proxy object that I very briefly went across, and Graham Dumpleton's talk will go into much more detail on that. So thank you, everybody.